In order to allow Pakistani enterprises to use affordable and durable motors, their workshops are prepared to make them by hand, even though they do not have high-end processing equipment. The finished products are very cost-effective. The motor shell is inseparable from sandcasting. Fu first fixed the shell on the base of the sandbox and compacted the sand filled inside. The first step is to mold the shell. When it is burnt, a new shell can be reproduced. Next, the master wrapped the iron sandbox on the outside and then filled it with sand from the mixer oil. In order to prevent the inside from being hollow, the master needs to repeatedly mine and compact it. Compacting is a crucial link. It can prevent the sand mold from cracking. After the completion of the compaction, the upper cover can be separated. Then dig a guide groove in the middle of the mold to ensure that the molten iron can be poured into the gap. Then the motor shell is pulled out of the mold. The motor mold for molten iron pouring has been simply made. At the same time, on the roof of the small workshop, Fu is adding raw materials to the boiler for melting. These scrap irons are recycled at very low prices, which can reduce the production cost of the motor. After heating, the scrap iron has melted into the shape of boiling hot molten iron. The masters use special rubber column barrels to pack it. Because there is a lot of iron slag in the molten iron, it must be cleaned before use. After the amount of molten iron in the rubber column barrel is sufficient, the molten iron needs to be poured into the mold at a uniform speed. Although the pouring process looks simple, it requires extremely high stability to ensure that the internal molten iron is completely sufficient. Before the molten iron solidifies and cools down, in order to avoid cracking of the shell, the master must pour it while it is hot. In this way, a brand new motor shell is obtained. However, these blanks do not meet the use requirements. The surface of the rubber column is very rough. Therefore, the shell needs to be fixed on the lathe claw plate, and then the inner wall is cut to ensure that the data of the shell meets the assembly standard. After the single cutting is completed, the next step is to install the stator core. This process is relatively simple. The master only needs to use the wolf head to knot continuously. After the secondary core is completely fixed, because the copper wire winding cannot directly contact the iron core, the groove inside the iron core silicon steel sheet needs to be manually inserted into the insulation value to prevent short circuit inside the motor. We all know that the motor drive mainly depends on the internal winding, so the copper wire needs to be manually wound. Although they do not have high-end automatic winding machines, each bundle of miscellaneous numbers can be done without error. Then the copper winding is inserted into the groove crosswise. When the winding is energized, it can generate a magnetic field and further drive the rotor to rotate. The principle of motor drive. Once the cross stacking of the same winding is completed, the next step is to connect the wires of the various parts of the motor. In order to avoid short circuit of the wires, the master needs to put the same length of internal high-temperature interconnection tube on the interface wire of each group of windings. In order to prevent the winding from being connected, the master also needs to use resistance welding paste to weld the interface to avoid the potential risk of poor contact. After ensuring the safety and firmness of the wires, in order to prevent the coil from shifting, the master needs to tighten the winding with nylon wire. In order to ensure that the internal winding can be completely insulated, a layer of insulating liquid should be poured on the surface of the winding. Although this step seems very simple, it is the key to avoid internal contact short circuit. After the insulation treatment is completed, the previously processed wires should be fixed. The contactor on the end cover is connected to the shell through screws. Then the new rotor is inserted into the interior. This completes the installation of the motor. Next, the motor should be powered on to test whether the internal rotor can work normally. To fix the starting capacitor on the surface of the motor, in order to avoid excessive load causing the motor to burn out, the master will use wood to tighten the rotating shaft to simulate the use of the motor in a normal environment. In this way, it can be tested whether there is a problem with the motor. Considering that the shell of the motor will rust, the master will first polish the surface to ensure that the surface is flat, smooth, and free of rust agents. In this way, the best effect can be achieved during the anti-rust period spraying. It not only improves the appearance of the surface, but also makes the motor more durable. After watching the entire manufacturing process, what do you think of the quality?